This is my pre-algebra course. Today we're going to review for test number 1. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. To prepare for the test, we're going to take a practice test today, and I'm also going to give you a practice test for homework. Now I want you to understand that the practice tests are not the only thing that you need to work on to study for the test. You need to look at the previous classes and combine that work with the practice test that I'm going to give you today. And I want to tell you the proper way to study for a math test and the improper way to study for a math test. The proper way to study for a math test is to give yourself problems and do those problems and obviously figure out if you get the right answer. Now, if you get the right answer on all the problems, then you do more problems. And you keep doing more and more problems, and you may get some wrong, you may get some right, but you keep doing more and more and more problems until you're absolutely sure that you're going to get the right answer every single time. So you get to the point where you're getting the right answer for every single problem, and then after you have done tons of problems and you keep getting the right answer over and over and over again, then you do more problems. And you just keep going until you're absolutely sure that you're going to get the right answer every time on every version of each problem. That's the proper way to study for a math test. If you're taking the course seriously, that's how you'll study for the math test. Now, if the improper way to study for a math test is you look at some problems. You may look at all the problems from the practice tests and the classes, and you try to attempt the problems, and you get maybe half of them wrong. Then you look at the ones that you did wrong, and you look at the right answer, and you say, okay, now I understand, and then you take the test. That's the improper way to study for a math test, because it's just careless. You're not being careful about making sure that you understand how to do the problems correctly. So I just want to make it clear that I'm not going to write another test. There's one test beside the test that I'm giving you today, the practice tests. I'm only going to give you one test. So I don't have time to sit around all day and write tests. So you have one chance to perform on that test. And if you don't perform well, then you're just wasting your time in this course. So the point I'm getting across is be sure that you know how to do these problems before you take that test, or else you're just wasting your time, and you're certainly wasting my time. So let's talk about the test. The test is going to have 25 questions, just like my previous course. Each question is worth 4 points. Now, if you have 4 parts for a problem, then each part is going to be worth 1 point for a total of 4 points. Again, each problem is worth 4 points. If you have a question that only has 2 parts, like this question, then each part is going to be worth 2 points. Again, for a total of 4 points for each question, each problem. And of course, if you have a problem with only one part, that part is going to be worth 4 points. So again, there's a total of 100 points, and I'll talk about how to grade the test in the next class before you take the test. So with that said, let's go ahead and start the test, the practice test that we're going to do together. And again, this is not the only thing that you need to study. You need to go over your class notes, or the previous classes that we did. You can watch those videos. All right, so number 1, part A, 2 minus 6 is negative 4. Part B, negative 5 plus 10 is 5. And be sure that you write the equal signs. Negative 7 plus negative 1 is negative 8. Write the equal signs and rectangle your answers. Negative 8 plus 7 is negative 1. Now, notice how fast I did those problems. You should be able to do those problems very, very quickly if you're fluent in adding or subtracting negative numbers, or whatever we're going to do on this test. I'm not really going to stop and explain all this, because again, this is just notation. You either know it or you don't know it. And you can go back to my previous classes and look at that stuff if you want more instruction. But the purpose of this class is really just to make you aware of what the test is going to be like. So negative 3 plus negative 2, that's negative 5. And by the way, you can pause the video and try to get these answers yourself if you want. That's probably a good idea. Negative 4 minus 7 is negative 11. And 8 minus negative 5, that's a double negative, so that becomes 8 plus 5. You may want to show that intermediate step. You don't have to, though. And then we have 13. And negative 6 minus negative 9. Let's see if you can do that one. If you said positive 3, then good job. Again, the double negative becomes a positive, and you end up with 3. All right, so that was adding and subtracting. And the one that's going to really cause trouble is this one. That's the one that students really don't like. So again, this is a condensed form of the notation. You're adding negative 4 and negative 7 to get negative 11. But you don't write parentheses and you don't write a plus sign. You just condense it into that form. Is it confusing? Yes. Do mathematicians care if you think it's confusing? No, they don't. You have to learn the language and just get used to it. So now we're going on to parentheses. Parentheses means multiplication. And we learned that when you multiply or divide negative numbers, unlike signs, you're going to get a negative answer. For example, you have unlike signs here. You have a positive 3 and a negative 6. So you're going to get a negative answer. And of course, to get the 18, you just multiply 3 and 6. But if you have like signs, you're going to get a positive answer. So unlike signs, they don't like each other, you're going to get a negative answer. Like signs, they like each other, you're going to get a positive answer. It's a positive situation. So now that rule does not apply. Please understand that rule does not apply to addition and subtraction. With addition and subtraction, if you're adding two positive numbers, obviously you get a positive. If you're adding two negative numbers, obviously you get a negative number. But if you're adding a negative number and a positive number, you have to figure out which one defeats. And if the negative defeats, your answer is negative. If the positive defeats, your answer is a positive. And you just have to subtract the two numbers to figure out what the actual magnitude of the number would be. But with multiplication and division, the rule is completely different. With multiplication and division, it's the like signs, unlike signs that I just mentioned. All right, so negative 7 times negative 8. Those are two negatives. They are like signs, so they like each other. It's a positive situation. So we have a positive answer. Again, you don't have to use that corny positive situation, negative situation example. You don't have to use that to figure out what the answer is, but that's just one way to do it. 8 times negative 1 is negative 8. They're unlike signs. They don't like each other, so it's a negative situation. All right, so negative 5 times 2 is negative 10. Negative 3 times 3 is negative 9. And again, notice that I'm putting these equal signs. A lot of students, what they're going to do is this. They're going to put, for example, negative 10 times 7 is negative 70, and they're not going to put an equal sign. If a mathematician or a scientist or an engineer looks at this, this is a ridiculous statement. It means nothing. Well, actually, it does mean something. It means that you're actually subtracting the negative 70 from this expression. They don't interpret it as being equal to. They don't know anything about that because you didn't write an equal to symbol. It's like you're going to tell somebody that you're going to go to the store to get some celery, and you say store celery go to. They're going to think that you're crazy because you're not using the proper syntax. You're not using the proper grammar. When it comes to mathematics, you have to have complete sentences, and you have to have the proper syntax and grammar. So, long story short, write those equal signs and rectangle your answers. If you don't rectangle an answer, I'm going to take a point off. All right, so that was multiplying, and we did addition and subtraction, and we did multiplication, and now we're moving on to division. So we show multiplication with parentheses, but we show division with a fraction sign. So negative 49 divided by 7 is negative 7. Again, at that positive situation, negative situation thing applies. Like signs, they like each other. Unlike signs, they don't like each other. So here we have unlike signs. They don't like each other, so it's a negative situation. 72 divided by 8 is 9. And again, notice that I'm doing this very quickly. You should be able to do these problems very, very quickly. That's why I gave multiple parts for each problem. All right, we have like signs in part C. 48 divided by 6 is 8. So it's a positive situation because they're like signs. And here, the negative is in front of the fraction. So in that case, you just kind of just leave it in front. There's no other negatives, so you don't have to worry about the negative becoming a positive. 54 divided by 9 is 6. So negative 6 on that one. And by the way, in the previous problems I was going to mention, notice that the parentheses are in all these different configurations. In this problem, you have parentheses on the right side. In this problem, you have parentheses on both of the numbers. In this problem, you have parentheses on the left side. I mean, you can put parentheses in many different permutations. You need to understand that. But the one permutation that you cannot use is when you put a 3 with parentheses, for example, and then a minus 7. That's not multiplication. You can't do it that way. So be very careful about that. You can't do it that way. I'm not going to put these problems on the test. I probably should, just to try to fool you, because that would not be 3 times negative 7. That would be 3 minus 7, which is negative 4. So that's the one permutation that you're not going to see when it comes to multiplication. All right, negative. So in problem number 5, we got whole numbers. You see all these whole numbers? Well, in problem number 6, we're not going to get whole numbers anymore. We're going to have fractions. But the same rules apply when it comes to negative numbers. So we have a negative divided by a positive, so we're going to get a negative. But we have to reduce the fraction. So those numbers are both divisible by 6. Divide both of them by 6, and you get 6 over 10. Now that's not reduced completely. We can keep going. So we can divide both sides by 2, and we get 3 over 5. Remember, you have to reduce completely. If you don't reduce completely, you're going to get points taken off. All right, so that looks correct. Just double checking that. All right, part B, you can divide both sides by 3 and you get, divide both sides by 5 and you get 3 over 10. And again, you can pause the video if you want to do these before I do them, because I'm doing this kind of quickly. All right, divide both those numbers by 6 and you get 4 over 6. And a negative divided by a negative is a positive. Let me see if there's an easier way to do that. I'm thinking there might be a quicker way. No, I guess not. So then we just keep going because it's not reduced completely. You have to use the fundamental principle of fractions, divide both sides by 2, and you get 2/3. All right, why don't you try part D, and when you come back, we'll do it together. All right, we're back. You're going to divide both sides by 2 to get 9 over 11. And the negative just hangs out there. So if you got negative 9 over 11, good job. All right, on to number 7. Now we have fractions. So you can't add fractions unless you get a common denominator. So multiply both sides of this fraction by 2 and you get 2 over 6. Again, you can pause the video if you want to try it on your own. And I do suggest that you pause the video and try these on your own before you watch me do them. 2/6 minus 5/6 is negative 3/6. But if you leave it as negative 3/6, you're going to get a point taken off because we can divide both sides by 3 and get 1 over 2, negative 1 over 2. Now you can put the negative anywhere you want. You can put it here, or you can put it here, or you can put it down here. But you cannot write the negative more than one time, and you certainly can't put the negative over here. So, but it's the most traditional, or the most common place to put it is right in front of that fraction line. All right, part B. So again, we need a common denominator. And that's going to be 12. You have to change the form of the fractions. So you have a common denominator. So all we did was just change the form of those fractions. And so now we're ready to add up because we have a common denominator, and we get -7/12. So if you got -7/12, good job. All right, so let's do part C of number 7. So I multiply both sides of this fraction by 5, and I multiply both sides of this fraction by 4. And now we have a common denominator. So now we can just add those up. They're both negatives, so you just add the negatives. 15 plus 8 is 23, so it becomes -23 over 20. And we cannot reduce that. Now that's an improper fraction, but unlike my previous course, you can leave improper fractions. We don't really care in algebra if you write the fractions as improper fractions. All right, part D. What do you think the lowest common denominator is going to be? Well, if you said 24, you're correct. So we multiply both sides of this fraction by 3, and we multiply both sides of this fraction by 4. And now we have a common denominator, and this is condensed notation. There's no parentheses and there's no pluses, but you're still adding -9 and -4, so that would be -13 over 24. And I'm sorry, we're kind of running out of room there. -13 over 24. All right, so now we have double negatives, and we're going to get a common denominator. What do you think the common denominator would be? If you said 18, you're correct. And by the way, you might try to get a bigger denominator. You can do that. You can use 54 if you multiply 6 and 9. That's fine. It's just that you're going to have to reduce at the end. It's best to get the lowest common denominator. 54 would be a common denominator that you can use. That's fine. In fact, we could also use 36. That's another denominator we could use. But you want the lowest common denominator. You don't want to deal with big numbers if you don't have to. So the double negative becomes a positive because we have two negatives right next to each other. Then we get 10 over 18. And you just add those up and you get 25 over 18. And I don't think we can reduce that. All right, so now we have another double negative over here, but this is an easy problem because we already have a common denominator. The double negative becomes positive. And notice that I'm out of room, so I can go down. That's perfectly fine to go down. -1 plus 4 is 3. But I have another problem. That's not reduced, so we can divide both sides by 3, and we get 1/3. So you're not going to have this problem where you're running out of room on your test because you're going to write the problems on a separate piece of paper, and you can just write the problems down as you well, actually, you probably don't want to do that because that's going to be a waste of time. So just leave yourself enough room on your paper. All right, so now we're going to multiply fractions. You see the parentheses, that means we're multiplying. So when you multiply fractions, you just multiply straight across. 4 times 3 is 12, and 7 times 4 is 28, and a negative times a positive is a negative. The problem is now you have to reduce. So you can divide both sides by, let's see here, divide both sides by 4, and you get 3 over 7, and that's your answer. Now, I just want to go back, and I want to show you an easier way to do it. So what we can do is we can keep it in factored form. 4 times 3, and I'm using a dot for multiplication. That's perfectly fine. And 7 times 4. So I'm just keeping it in factored form, and you're probably thinking, well, why in the world would you do that? Well, the reason that I did that is because, look, I see that the 4's can cancel out. And so I didn't have to use any energy to recall my multiplication facts. Now I just know that the answer is 3/7, negative 3/7. And if I wanted to, I could actually just cross these out and see immediately and just write 3/7. But please understand that you cannot mess up the original problem. When somebody looks at your test, when somebody is going to figure out what you've learned, when a parent or a teacher or somebody looks at your test, they want to see the problems that you're required to do. Well, if you're crossing out all kinds of stuff in the original problem, it's hard for them to see what the original problem was. So they can't really see a record of your work. So don't mess up the original problem. So this is really the best way to do it. All right, so part D, we're multiplying fractions again. And you see that there's no common factors. Well, actually, I take that back. There is a common factor. So negative times a negative is a positive. And I'm just going to write 1 times 2 because I see the common factor, and 4 times 3. Now, at this point, we don't immediately see a common factor, but if you factor 4, it becomes 2 times 2, and now you can see that there's common factors. So you cancel out those 2's, and you end up with 1 over 2 times 3, which is 6. So again, the 2 and the 3 are left, and you just combine those. 2 times 3 is 6. All right, so now we're dividing, but you have parentheses because you can't put a division sign next to a negative sign. That's non-standard math notation. So the reason we have parentheses is to avoid that non-standard situation. So do you remember how to divide fractions? If you don't, then we'll just go over that right now. When you divide fractions, you flip the divisor, so it becomes 4 over 5, and you change the sign to multiplication. Now we show multiplication with parentheses, so all I did was just keep those parentheses and get rid of that division sign. So now we're going to multiply straight across. Whenever you multiply fractions, you just multiply straight across. Multiply the numerators and multiply the denominators. But I see we have a common factor, so I'm going to go ahead and write 3 times 4. I'm going to keep it in factored form. And then I'm going to factor the 8 to 2 times 4. And you can see why I did that, because I have a common factor. So the 4's are going to cancel out. And you're going to be left with negative 3 over 2 times 5 is 10. So negative 3/10. And again, I'm sorry that we're running out of room here. All right, let's see here. Rewrite the dividend, get rid of the division sign, flip the divisor, and now we have multiplication. And a negative times a negative is a positive, and I'm going to keep it in factored form because I can see that we have common factors here. So now I'm going to factor 4. I'm going to make 4 2 times 2, and you can see why I did that. We have a common factor, so we're going to cancel out those 2's. And we get, and I'm going to have to do a divider here, we get 5 over 6. All right, so now part C, we're just adding a bunch of negative numbers. Negative 5 plus negative 3 is negative 8. Negative 8 plus negative 1 is negative 9. And now we're multiplying 3 numbers, so negative 3 times 4 is negative 12. And negative 12 times negative 2 is positive 24. Now that's not one of our multiplication facts, but you can always do it on over to the side here if you want. 2 times 2 is 4, 2 times 1 is 2, 24. Also, I forgot to mention that I'm not going to allow you to use a calculator on any of these problems except the decimal problems. In fact, that's the way it's going to be in this entire course, this pre-algebra course. Do not use a calculator except on the decimal problems. And technically, you don't really even need a calculator on those problems, but just to make things faster, you can go ahead and use a calculator. All right, so number 10, negative 4 plus 2 is negative 2, and negative 2 minus 8 is negative 10. Again, you can stop me and try these problems. I suggest that you try the problems on your own before you watch me do them. 1 minus 3 is negative 2. Negative 2 plus 6 is 4. All right, part C, negative 6 minus 9 is negative 15. This is condensed notation. Negative 15 minus 4 is negative 19. So if you got negative 19, good job. 2 plus negative 10 is negative 8. And negative 8 plus negative 1 is negative 9. And negative 9 plus 18 is 9. And if you're going down, it's probably best to keep going down. But again, I didn't really leave myself a lot of room here, so I should have been more prepared for this. You want to make your work as neat as possible, and I'm not really doing that here. But that's no excuse for you to not do that. Your work needs to be neat because you're keeping a record of your work. All right, negative 9 times negative 1 is positive 9. 9 times negative 9 is negative 81. I thought that I spaced these out properly, but I guess I didn't. That's my fault. 4 times 2 is 8. 8 times negative 8 is negative 64. All right, part C. We're going to add 3 fractions together. Some of the fractions are negative and some of them are positive. Now, a lot of students would say, hey, wait a second, you're not adding this fraction, you're subtracting 2/5. Well, technically, you're still adding because subtracting a positive number is the same thing as adding a negative number. Now, I know that that blows a lot of students' minds, but don't overthink it. That's just how this stuff is interpreted. So we cannot do this unless we get a common denominator. But first, we can go ahead and add the negative 4/5 and the negative 2/5 because they already have a common denominator, so then we get negative 6/5. So we have negative 6/5. And then we're going to have to go off to the right here because we're running out of room. Multiply both sides of this fraction by 2, and you get negative 12 over 10 plus 1/10. And negative 12 over 10 plus 1 over 10 is negative 11 over 10. Now again, notice how I wrote the negative here. It's not wrong if you write it next to the 11, like so. It's not wrong if you put it up here. And it's not technically wrong if you put it down here either, but it's very non-standard to put it down there. All right, so we're doing good. If you're sticking with me, then you're doing good. All right, now we're going to multiply. We're going to get a common denominator. So we're going to multiply both sides of this fraction by 2. You're going to multiply both sides of this fraction by 4. And there you go. So now you have a common denominator. You can add all those up. Negative 2/8 minus 3/8 is negative 5/8. Negative 5/8 plus 4/8 is negative 1/8. So if you got negative 1/8, good job. All right, on to number 12. Now we're multiplying 3 fractions, but the principle is the same. You just multiply all the numerators and then multiply all the denominators. So 2 times 1 is 2. 2 times 3 is 6. And I know our answer is going to be negative because, you know what, I should probably do this in, well, no, I'm not going to do that. So a positive times a negative is a negative, and then a negative times a positive is a negative. So I know that our answer is going to be negative. So I multiplied all the numerators straight across, and now we're going to multiply the denominators. 5 times 4 is 20, and 20 times 4 is 80. Actually, I'm going to go back because now I see we have a common factor. So I'm going to go ahead and leave those in factored form. And I'm using dots for multiplication. That's just the standard way to show factorization is with dots. You could use parentheses if you wanted to. Alright, so the reason I left that in factored form is because when you factor one of those 4's in the bottom, you get 2 times 2. I don't have to factor both of the 4's, just one of them. And you can see now that those 2's cancel out. This 2 has to remain because there's only one 2 up here to cancel out 1 2 in the bottom. Alright, and so I can just combine the rest. So 1 times 3 is 3, and 5 times 2 is 10, and 10 times 4 is 40. So I get negative 3/40. Alright, on to part B. So this is condensed notation. And don't forget this -1 part. We have condensed notation here, but we're just adding a bunch of negative terms. So the lowest common denominator is going to be 18. And the big question is, what do we do with that 1 right there? That's not a fraction. So how do we deal with this? Let me double check my other numbers, make sure those are correct. Yep. So the way that we deal with this is we move that 1 up a little bit. Whoops, I distorted it. So we move it up a little bit and we change it into a fraction. Remember, you can write any whole number as over 1, but I'm not going to mess up the original problem. You got to keep your original problem there. So you can think of that as 1 over 1. So then you can use the fundamental principle of fractions, and you can take 1 over 1 and just multiply both sides by 18, and it becomes 18 over 18. Obviously, if you have a pizza and you cut it into 18 parts, but you don't eat any of it, it's just 18 out of 18, which is one whole pizza. And the same is true with any whole number. Let's say that you get -3. Then you can write that as over 1. You can always write a whole number as over 1. Then you multiply both sides by 18, and you get your fraction. It's going to be an improper fraction, but it's going to be a fraction nonetheless. Alright, so now we're going to add those up. So -3, and again, that's condensed notation, but you're just adding all those negatives. -3 plus -16 plus -12 plus -18. So add those and you get, let's see, -19, then -20, -31, and -49, I believe that is. And I don't think that you can reduce that. You can keep it as a whole number, or as an improper fraction. But if you have to reduce it, then you need to reduce it, but I don't think we can reduce this. So let's just double check that. And it looks correct. Alright, so now we get to the decimals. So the point of multiplying or dividing or adding or subtracting decimals is just to show you that the same principles apply to decimals. So a negative times a negative, and again, we know this is multiplication because we have the parentheses here, you see? We have those parentheses, and there's nothing in between the parentheses, so that means because the numbers are just right up against each other, it's multiplication. So a negative times a negative is a positive, so we know the answer is going to be positive. But you can get your calculator to figure out what the number, what it's actually going to be. So 1.058. And by the way, if you try to cheat and use your calculator for the other problems, you're going to find it's not as easy as you think to use your calculator to calculate what those answers are going to be. So don't try to cheat and use your calculator on the other parts of the test. All right, so now we're gonna do 57.7 plus negative 3.3. Now I said that when you're adding or subtracting negative numbers, it's all about which number defeats. If the signs are different. You know, we have a positive number and we have a negative number, a positive and a negative. So in this case, we have to figure out which one defeats. But when you're adding two positive, or if you're adding two negatives, obviously they just add up. But when you're adding a positive and a negative, you have to subtract the numbers actually. So first we figure out which number defeats. Is the positive bigger or the negative? Well, technically, a negative is always smaller than a positive, but I mean the magnitude of the number. The magnitude of the number is when you just ignore the sign and you just look at the number itself. So obviously, the magnitude of this number is much bigger. So that means the positive is going to defeat. So our answer is going to be positive. And then to figure it out, you just subtract 56.7. You just figure out the difference between those. So you want to figure out how much does it defeat? By how much does it defeat? So 56.7 minus 3.3 is 53.4. So again, this situation is if I have 56.7 grams of gold and you have 3.3 grams, how much more do I have? That's what this problem is asking, pretty much. All right, so that was just negative numbers. Now we're going on to variables. The second part of this test is going to be variables. So negative 5x plus 6x is 1x. But we don't write that 1. Don't write that 1. Just write x. If you become an engineer or a scientist and you write 1x, then the engineers are going to laugh at you. They're going to say, why is he doing that? It's standard, it's traditional just to write the x by itself. All right, part B, 9y minus 11y is negative 2y. Again, you should be stopping the video and attempting these problems on your own. Don't just watch me do them. Negative 6z minus 4z is negative 10z. So if you got that right, good job. Again, that's condensed notation. A lot of students don't like that notation because it's hard to understand. Don't try to understand it, just memorize the notation. That's just condensed form of negative 6z plus negative 4z. That's all that means. I said try not to understand it, but what I meant was understand it as negative 6z plus negative 4z. Don't try to understand it as negative 6z minus 4z, because that's trying to understand something that doesn't really make a lot of sense in the real world or in the math world. All right, so negative 14x plus 8x. If you got negative 6x, good job. So now we're going to multiplication actually no, that's not multiplication, that's a double negative. You're subtracting a negative. The negatives are right next to each other, so you're subtracting negatives. So because it's a double negative, it's just going to become positive. And now it's just 6x plus 10x, which would be 16x. All right, we have another double negative, but on this problem, the only difference is you have a negative on this number too. So then it becomes negative 3y, and these negatives become positive. This negative does not become positive. It's just the negatives that are next to each other. They become positive 5y, and then bring that down. Negative 3y plus 5y is 2y. So if you got 2y, good job. All right, so now we're multiplying. We're multiplying variable expressions. So when you multiply, it's very easy. First you do 2 times -3, which is -6. So you do the numbers first, also called coefficients. We've used that term. At least I think we have. I don't remember. But the numbers that go right next to the letters, they're called coefficients, if we haven't mentioned that previously. All right, z times z, you're multiplying them, so it's z to the second power because you're multiplying 2 z's. Remember, power notation is a condensed form of multiplication. When you're multiplying something by itself, you can use power notation. For example, if you're multiplying 4 times 4 times 4, you can write that in condensed form as 4 to the third power. Why the third power? Because there's 1, 2, 3. 1, 2, 3. So go ahead and rectangle that. All right, now we're dividing. So 16 divided by 8 is 2. And over here, we added the powers because we were multiplying. Here you have power 1 and power 1. You multiply them together, you add the powers, and it becomes power 2. But here you're subtracting the powers. So there's 1. We don't see the power here, but it's always a 1 power. And you're going to explain why that is more in courses that are going to come later. But so 3 minus 1 is 2. So there's 2 x's, x to the second power. All right, so number 15. Again, we're multiplying algebraic expressions, so -3 times -9 is 27. Do the numbers first. X to the fourth power times x to the first power is x to the fifth power. Y to the first power times y to the first power is y to the second power. Z to the third power times z to the fifth power is z to the eighth power. So as you can see, it's no big deal. It's pretty easy. And part B, 5x minus 10x is -5x. And -5x minus 11x is -16x. All right, so now we're multiplying 3 algebraic expressions. 20 times -1 is -20. So I'm going to multiply these first. And x to the second power times, there are no x's in this expression, so we just write x to the second power, and then y times y is y to the second power. And I'm just going to rewrite the other term. You don't really have to do it in steps, you can do it all at once, but I'm just going to do it in steps so you can see what's going on here. So all we did in the first step was we multiplied this -y into the 20x squared y. So -20 times 4 is -80. X squared times x is x cubed, and notice that this x comes first in the first term, but the x comes last in the second term. That's okay. It doesn't really matter because of the commutative rule of multiplication, which we learned in the previous class, or previous course. And y to the second power times y to the second power is y to the fourth power. And the z in the second term just stays there because there's no z's in the first term. So everything looks correct. Double check. You really want to double check everything when it comes to algebra because it's so easy to make a mistake. And unfortunately, with algebra, you make one mistake and your entire answer is wrong. That's one of the reasons students really don't like algebra. All right, so -63 divided by 9 is a -7. I'm just going to put the negative on that side there. And x to the fifth over x to the seventh, so we're subtracting. So 7 minus 5 is 2. but the x's are going to end up on the bottom because there's more x's on the bottom than on the top. So whatever's left over is going to end up on the bottom. And 2 minus 1, we have 1, so 2 minus 1 is 1, so there's going to be 1y, but the y, again, is going to be in the bottom because there's more y's in the bottom than on the top. And 7 minus 1 is 6, but there's more z's on the top than on the bottom, so the z's are going to end up on the top. These are very, very simple rules to memorize. The question is, do you have the motivation to memorize them? And hopefully you do, because you're going to be able to accelerate in the math curriculum far beyond what any student in the world is going to be able to do if you simply follow my directions and get the homework done and study for tests. All right, so let's double check that, and everything looks good. So on to number 17. Again, we're just simplifying this fraction. So in this case, we're just going to reduce the fraction. So divide both of those numbers by 5, and you get 4 over 5. And a negative divided by a negative is a positive. When you see two negatives in a fraction, the fraction is just going to become positive. And we're going to be left with 1a on the bottom, 2 b's on the top, and the c's have the same powers, so they're just going to disappear completely, because 2 minus 2 would be 0. And anything raised to the 0 power is actually just 1. It just disappears. Now, we're not going to talk about why that is until you take intermediate algebra, which is, it's going to be a while before you take that course. It really just depends on how fast you want to go through the curriculum. You can probably take it in the next, 3 or 4 months if you really wanted to. Just depends on how fast you want to go. All right. On to part B. Again, multiply the numbers first. Negative 8 times 5 is negative 40. X to the 10th power times x to the 3rd power is x to the 13th. Again, you're just adding the powers because we're multiplying. Y to the 6th times y to the 4th is y to the 10th. And the z just hangs out there. So if you got that answer, good job. All right, so we're dividing again, but something special is going to happen here. There's not going to be any numbers in the numerator. Divide both of these numbers by 9, and using the fundamental principle of fractions. Again, we're just reducing. Use the fundamental principle of fractions. 9 divided by 9 is 1. 36 divided by 9 is 4. And again, it's not standard to write the negative in the denominator. It's not wrong, it's just not traditional to do that. So we're going to write the negative there. And we're going to end up with x to the 4th and y to the 2nd and z to the 3rd. Now, there's one important thing here that's going on, and that is this 1 is typically, like I mentioned, this 1 is typically left off because it's just not necessary to write it. So we just leave that 1 off, and let's rectangle our answer, and there you go. All right, part B. So use the fundamental principle of fractions. Divide 8 by 8, you get 1. Divide 32 by 8, you get 4. We're just reducing. And x to the 5th and y to the 3rd. So now in this case, we're going to keep the 1 in the numerator. We're not going to make it disappear because we need something in the numerator. If we made the 1 disappear, then that would look very strange because it looks like the fraction is incomplete. So in that case, when there's nothing else in the numerator, we do need to write a 1. And the same situation is true when there's nothing in the denominator. Well, actually, that's not the same situation. If you have letters here and you have a 1 in this as this coefficient, you don't need to write the 1. But if you have nothing down here, then you don't need to write a 1 in the denominator. For example, up here you could write over 1, but you don't really need to. All right, so let's rectangle that. So now we're subtracting algebraic fractions. The good thing is we have a common denominator. So, and by the way, this is just an x by itself, so you know what that means. It means there's a 1 right next to it. That's just considered to be 1x. So we have a common denominator. We don't have to get a common denominator, and we're ready to go ahead and combine those fractions. So 1x minus 2x is negative 1x. And that's it. But again, we don't write that negative 1. We just write it as negative x over 7. It's not wrong to write the negative 1. It's just that the engineers and scientists are going to laugh at you. All right. So now, in this case, we don't have a common denominator. So that's a problem. So we're going to have to multiply both sides of this fraction by 2. And we get 2y over 8. So now we have a common denominator. So now we can go ahead and add those up. Negative 3y over 8 plus 2y over 8 is negative y over 8. Again, I don't write the 1 in front of the y. You don't need to. All right, so now we're going to combine more than 2 algebraic expressions. Negative 1x plus 4x is 3x. And 3x minus 3x is 0. Negative 8y minus 9y is negative 17y. Negative 17y minus 10y is negative 27y. And again, this y has no coefficient on it. There's no number in front of it, so that just assumes that the number is 1. So negative 27y plus 1y is negative 26y. Alrighty. So now we're multiplying algebraic fractions. Let's see here. I'm going to go ahead and keep those numbers in factored form because I can see that we're going to be able to reduce something. So when you're multiplying fractions, you just multiply the numerator straight across and you multiply the denominator straight across. So we're going to start by multiplying the numerators. And I know my answer is negative because a negative times a positive is a negative. A negative times a positive is a negative. So 5 times 3, I'm going to keep it in factored form, but x times x to the second power is x to the third power. And I'm just going to have to write that y and z because there's no y's and z's in the numerator on the first term. All right, and instead of writing 6 times 4 is 24, I'm just going to keep it in factored form, 6 times 4. And y to the second power, there's nothing to combine it with, and z, there's nothing to combine it with. All right, so we have negative, and I'm going to go ahead and factor 6. 6 becomes 2 times 3, and you can see why I did that, because now we have a common factor. We can cancel out that 3. Now again, you can multiply straight across and get 15 over 24. It's just that you're going to have to reduce it, so it's kind of an extra step. But that's perfectly fine if you want to do that. You don't have to keep it in this factored form. So if you got 15 over 24, then you just use the fundamental principle of fractions and you divide both of these by 3 to get 5 over 8. That may be a faster way to do it. If you want to do it that way, that's fine. But I just want you to see that you can go straight to the answer if you just cancel out those 3's. All right, and we get x cubed and we have y over y squared, so you just subtract those powers and you get 1y in the bottom, and the z's just cancel out. And again, the reason the y ends up in the bottom is because there's more y's in the bottom than on the top. So we cancel out, and it looks like our final answer is going to be 5, and then combine the 2 and the 4. 2 times 4 is 8. Again, the yellow numbers go away, they disappear. And x cubed over y. And there you go. All right, so we're on number 21. We're getting there. We're almost done. We got 1, 2, 3, 4 more problems. All right, so now we're dividing algebraic fractions. So you tell me, how do you divide fractions? What's the standard way to do this? Well, you just have to rewrite the dividend. And then you take the divisor, and then you flip it. So we're going to flip that divisor. All right, and then you're going to get rid of the division sign because now it becomes multiplication. Again, you just flip the divisor and change to multiplication. But because we're doing algebra here, multiplication is just shown with parentheses. So when you get rid of that division sign and put the parentheses right next to the other fraction, it becomes multiplication. Is that a lot to remember? Yes. But that's just algebra. There's a lot of operations and signs and things that you're going to have to remember. Notation and whatnot. So now we're ready to multiply straight across. And I'm going to go ahead and write it down. I'm going to go down instead of to the right. So 7 times 6, I'm going to keep it in factored form because I see something's going to cancel out here. And our answer should be negative. I don't have room here, so I'm just going to put it in the numerator. Multiply the numerator straight across. Z to the 6th times z to the 4th is z to the 10th. And we just combine these x's and y's, but there's no x's and y's over here, so you just rewrite these x's and y's in the denominator. All right, and now we just have to reduce. So that 6 becomes 2 times 3. And that's why we don't like using dots in algebra, because if you don't use them properly, they look like decimals. So you can see the 3's are going to cancel out, and x to the 4th over x, that's just going to be 1x on the top. And then y to the 3rd over y to the 3rd, the y's are just going to disappear. So we're almost done. We just have to cancel out those 3's. Seems like there's a lot of problems that we're doing where we're canceling out 3's. So we have a problem because there's really no more room at this point. So I'm going to have to go ahead and move this problem down. I've got no choice. All right, so equals, and negative 7 times 2 is negative 14, and the 5 just remains, and the x and the z to the 10th just remain. So that's our final answer. So you got that? If you got that answer, good job. Let me just double check that. Everything looks right. All right. So now we just have 3 more problems left. So now we're adding fractions. You have to get a common denominator. And what do you think the common denominator is going to be? Well, if you said 36, you're right. Multiply both sides of this fraction by 9. Multiply both sides of the next fraction by 4. And this is a whole number term. So remember, when you have a whole number term, you can just consider it to be over 1. So multiply 2x over 1, multiply both sides of 2x over 1 by 36. And that's actually a pretty big number. So 36 times 2. We know 36 times 1 is 36. But 36 times 2, that would be 72. And you can just write it off to the side if you want. 6 times 2 is 12. 2 times 3 is 6. 6 plus 1 is 7, 72. Again, we learned how to do that in the previous course. So you end up with 72x. Then we have a double negative, so that becomes a positive. And we're going to have to multiply both sides of this fraction by 12 to get 24x over 36. I know that's not part of our multiplication facts that we learned in the previous course, but sometimes you're just going to have to do calculations that require slightly bigger numbers. And you can do it off to the side if you want. They show the work there. All right, so I think we're ready to go at this point. We've got a common denominator. Negative 27x plus 4x is negative 23x. Negative 23x, well actually I should probably just show the steps here. I've got enough room to show the steps, so I might as well. So now we're going to add negative 23x and 72x. And again, you can do that off to the side if you want. It'll be 72 minus 23. You borrow and you get 12 and 9 and 4, so it's going to be 49. So we get 49x over 36 plus 24x over 36. And 49x plus 24x is 73x over 36, I believe, and you cannot reduce that. But again, you can do that off to the side. 49 plus 24. 4 plus 9 is 13, carry the 1. Add these numbers, and 4 plus 1 is 5, plus 2 is 7, 73. Now, if you're bewildered by this, then that probably means you didn't take my previous course. Just go back and take, and if you want to know arithmetic algorithms, just go back to my previous course. Again, the prerequisite for this course is my arithmetic course, or any kind of arithmetic course that you may have taken in school, or if you may have been homeschooled. You need to take some sort of full arithmetic course before you can take this course. So I'm not going to explain how to add 49 and 24. That's something you should have learned in the previous course. Math has prerequisites. A lot of students get into the wrong course, and then they ask their teacher to explain things from previous courses. That's really not their job to do that. That's why there's a prerequisite. That's what prerequisite means. It means you should have taken a course to prepare you for this one. All right, so now part B, negative 2y plus 2y. That's going to be 0. So that was an easy one. All right, so if you've gotten this far, you're doing good. This class is not going to be a very long class. It looks like it's going to be about an hour and 15 minutes. So now we're dividing again, but we're dividing what appears to be a fraction with a whole number term. Again, there's no way to know for sure if this is a whole number unless you know what B and C are, but we just assume it's a whole number because it looks like a whole number. So whenever you have a whole number term, you want to write it as a fraction, so you just write over 1. But again, I'm not going to mess up the original problem. So just rewrite the dividend. get rid of the division sign and flip the divisor as usual. That's just how you divide fractions. We already talked about that once today. You change this to multiplication and you flip the divisor. And because this divisor is over 1, it just flips to 1 over. And because you're changing to multiplication, all you have to do is get rid of that division sign, and it becomes you just write your parentheses, because parentheses is multiplication. All right, so now we're multiplying fractions, and whenever you multiply fractions, you just multiply the numerator straight across. So we get negative 2a squared b cubed, because whenever you multiply something by 1, it doesn't really change it. And when you multiply the denominators, 5 times negative 3 is negative 15. And we just rewrite that b squared, and c times c is c to the second power. All right, so now we can't really reduce 2 over 15, but we know a negative divided by a negative is just a positive, so we can just get rid of those negatives. A to the second power, there's nothing to combine it with, but we do have b to the third power over b to the second power. We can combine those b's. There's more b's in the top than in the bottom, and 3 minus 2 is 1, so we have b in the top, and there's no more c's to combine, so we just write c, and that's our answer. Wait, I'm sorry, that should be c squared. I almost missed that c squared. All right, so let's just double check that. Everything looks right. And on to the last problem. So now we're multiplying what appears to be a whole number term with a fraction term. So again, whenever you multiply a fraction with a whole number or divide a fraction in a whole number, you want to write that whole number term, or what appears to be a whole number term, as over 1. So just think of that as over 1. And so you just multiply, and I'm going to go ahead and do that, because things are going to get kind of weird unless I go ahead and show that. So I'm going to rewrite that term. But except I'm going to write it as over 1. So again, it's the same thing as over 1. And then I'm going to rewrite the other terms. I probably should have just copied that whole thing. So the only thing that I did here was I'm showing you that this term is just going to be written as over 1. No big deal. So now we have two fractions, and we're ready to multiply those fractions. So you tell me, how do you multiply fractions? You should know this by now. We did this in the previous course. We did this in this very class multiple times. The way that you multiply fractions is to multiply straight across in the numerator and multiply straight across in the denominator. So in the numerators, we have negative 5 times 9 is negative 45. And x to the 7th power times x to the 5th power is x to the 12th power. And y to the 3rd power times y to the 3rd power is y to the 6th power. And then we have z to the 8th. In the denominators, we have 1 times 10 to the 7th, but when you multiply something times 1, it doesn't really change it. So you just get 10 z to the 7th power. Alrighty. So I think we're ready to reduce. I'm just double checking everything. Everything looks right. Again, with algebra, there's so many symbols, so many things that you have to keep track of. You really have to go back over again and again and again to see if everything's correct, because if you make one mistake, like I said, the entire answer is going to be wrong. So now we're ready to reduce, and I just realized that I probably should have kept that in factored notation, because we can reduce those numbers. So that's just going to be 5.9 and 10 down here. So now I'm going to factor the 10, and that becomes 2 times 5. And you can see why I factor the 10, because we have a common factor. So those 5s are going to cancel out. And let's see here. So x to the 12th, there's nothing we can do with that, so we just keep that. y to the 6, there's nothing we can do with that. There's nothing to combine it with. But the z's we can combine. So there's 8 and a 7, so 8 minus 7. You always subtract whenever you're dividing, because remember, this fraction sign means division. So whenever you're dividing terms with powers, you subtract the powers. If, of course, you have the same letter. You can't combine powers where you have different letters. So we're just going to subtract. 8 minus 7 is 1. But does the z end up in the top or the bottom? Well, it ends up in the top. And how do I know that? Because there's more z's in the top than on the bottom. So the leftover is going to end up in the top. So now we just cancel out those 5s and we end up with negative 9 x to the 12th y to the 6th z over 5. And that is our final answer. So let's just double check that. Make sure everything, and of course, I made a mistake there. That should be a 2. All right, so double checking. So that's why you want to double check. That's the typical kind of mistake that you can make in algebra. It's very easy to make that mistake. So we have negative 9 over 2, x to the 12, y to the 6, z. And so that's our final answer. So that's what the test is going to be like. It should take you between 1 hour and 2 hours. If you want to finish it in 30 minutes, you can do that if you want to go that fast. But just remember, the faster you move, the more likely you are to make mistakes. What you can do is try to finish it in 30 minutes and then spend a good 10 minutes checking over your answers. But again, you don't have to go that fast. If you want to take 2 hours, you can take 2 hours. That's fine. Just remember that the longer you use, the more time you spend on the test, the more your energy is going to be drained. This is all the work that we did today. If you'd like to take screenshots of these pages to help you with your homework or to study for tests, go ahead and do that now. All right, so let's go ahead and look at the homework. As you can see, for the homework, you have another practice test. This is practice test version 2. Also notice that you have all the answers. You need the answers. You need to make sure that you're doing these problems correctly. So do this practice test completely and correctly. Use equal signs wherever you need to. And rectangle your answers. Put your name, the date, so on and so forth. So let's get screenshots here. Get a screenshot of that. And a screenshot of that. And a screenshot of that. So get that practice test done. And remember, the most important thing to understand is that these tests, the test we just did, and also the practice test for homework, that's not necessarily going to be enough to help you study for the test. You need to do enough problems to where you're absolutely sure that you're going to get the right answer. So when you take that test, you're going to pass it, and you're going to be able to go on to the next subject that we're going to learn, or the next class. Again, I'm not going to write more than one test because I'm not going to sit around writing tests all day long. That's the test that you get. Do well on it and go on to the next class. But if you're lazy and you don't study for the test, then you're just going to be wasting your time. So again, this is all for you. This is for your advancement in the academic world. So if you don't pass that test, you don't advance and you're just wasting your time. So for your sake, study for the test and pass it the first time. So that was the class today. The next class is going to be test number 1, so I'll see you then.